Hello everyone, today I'll talk about the solution of the problem minimum bit flips to convert number. We want to convert start to goal using only single bit flips, and it's easy to see that the number of steps that we need to take is exactly the number of positions, so maybe let's do something like this, exactly the number of positions where they differ. So either, maybe let's add a 0 here and a 1 here. So either the first number has a 1, the second number has a 0, or the reverse. The first number has a 0, the second number has a 1. So we can go through all the possible positions, so for all the powers of 2, and see if the remainder, when dividing by that power, is different for the two numbers. So essentially when you divide by that number, so bit shift, discard the last part, if one number is odd and the other is even. But there is a bitwise operation that can be used to determine almost exactly what we want to do here, because it's a bitwise operation that with those two operands will give us exactly ones on positions where the two numbers differ. And that operation is binary XOR, right? Exclusive OR. It's called exclusive OR because it's true only when either one or the other is true, so either it's a 1 and a 0 or a 0 and a 1, but not when both are ones. And so if we have this XOR, then we just have to count the number of ones in that XOR. And again, we can do it by just repeatedly seeing if the number is odd and dividing it by 2. Or we can use the built-in function to calculate this so-called population count, which is what we can do in Python. So we take our two numbers, start and goal, and we XOR them together. This is this operation. Of course, this shows us that converting from start to goal and from goal to start is the same thing. And now we just have to count the number of bits, so the number of ones. This is how you use a population count, use a pop count in Python, and this is the value that we return. So this is probably the shortest and most straightforward way to solve this. And of course, it's also not a very, let's say, artificial operation, because often, for instance, when you're generating some subsets, then it might be important to say how many different, so what's the size of this symmetric difference between the two sets. So elements that are in exactly one set but not in the other. And if the sets are represented as bit masks, then this is exactly the operation you'd want to use.